States of matter, first key points. Next we will discuss objective questions. So first we will see key points. So STP conditions. STP condition means standard temperature and pressure. So standard temperature is 273 Kelvin. So standard pressure is 1 bar. Next different gas laws are present. So Boyle's law. Boyle's law means at a constant temperature and given mass of the gas, volume of the gas is inversely proportional to pressure. V is inversely proportional to pressure. Next Charles law. At a constant pressure, the volume of the given mass of the gas is directly proportional to absolute temperature. Here pressure and N means number of moles. Constant volume is directly proportional to absolute temperature. That is Charles law. Next Gay-Lussac's law. At a constant volume, the pressure of given mass of the gas is directly proportional to absolute temperature. That is Gay-Lussac's law. Next one Avogadro's law. At constant temperature and pressure, volume of the gas is directly proportional to number of moles or molecules. So otherwise, equal volumes of all gases contains equal number of moles or molecules at constant temperature and pressure. Equal volumes of all gases contains equal number of moles or equal number of molecules. So next one, ideal gas equation. PV is equal to nRT. By using Boyle's law, Charles law, Avogadro's law, PV is equal to nRT. So P is equal to N by V RT. So P is equal to N means number of moles. Number of moles formula weight by gram molecular weight. Weight by gram molecular weight into V RT. P is equal to weight by volume means density. Weight by volume means density. D into RT by M. So we know if we want D is equal to PM by RT. So many problems are there based on density. So D is equal to PM by RT. Next question. Next one, universal gas constant R values. By using these values, different problems we solved. 0.081 liter atmospheres Kelvin inverse mole inverse. If the volume is given in liters and pressure is given in atmospheres, use R value 0.081 liter atmosphere Kelvin inverse mole inverse. If joule Kelvin inverse 8.314, if calories are given 1.987. So by using these formulas, we will discuss some problems. Okay, next one, Dalton's law. Total pressure is equal to sum of the partial pressures of all the gases, P1 plus P2 plus P3. So next, partial pressure. If you calculate the partial pressure of the gas is equal to total pressure into mole fraction of that gas. If you want partial pressure of O2 in mixture of N2 and O2, partial pressure of O2 is equal to total pressure of N2 and O2 into mole fraction of O2. If you want O2, here O2. If you want N2, here N2. So next, Dalton's law of partial pressure is not applicable to mixture of reacting vapors. So one question asked, Dalton's law of partial pressure is which of the following is not applicable for Dalton's law of partial pressure? So examples, this one, COCl2, NOCl2, H2and Cl2, CH4 and Cl2. Shortcut, COCl2, NOCl2, H2Cl2, CH4 Cl2. All are chlorines. Here different gases, CO, NO, H2, CH4. Here two oxygens, CO and O2, next NO and O2. H2F2 and H3HCl. H2Cl2 and H2F2. So next HCl, ammonia. Ammonia and HCl also not reacted in normal conditions. Okay, next one. Moist gas pressure. Pressure of moist gas is equal to pressure of dry gas plus aqueous tension. It is also used in problems. Next, Graham's law. We know that Graham's law is rate of diffusion of gas is inversely proportional to square root of its density. R is proportional to 1 by root D. So R1 by R2. Different diffusions. Square root of D2 by D1. Density is directly proportional to molecular weight. That's why square root of M2 by M1. So it is directly proportional to vapor density. So molecular weight is equal to formula 2 into vapor density. That's why vapor density of second gas by vapor density of first gas. So next, R equal to V by T. What is the meaning of V by T? Rate of diffusion means volume of the gas diffused in a given time. Volume of the gas diffused in a given time is called rate of diffusion. So R is equal to V by T. Volume time. So different diffusions, R1 by R2 is equal to V1 by V2 into T2 by T1. So very important one. Next, kinetic energy formula. It is represented by EK, kinetic energy, 3/2 nRT. For n moles gas, 3/2 nRT. For 1 mole gas, 3/2 RT. For 1 molecule of the gas, 3/2 kT. K means R by N. Here R means gas constant, N means Avogadro number. The gas constant per molecule is called Boltzmann constant. Okay, note this. So next, types of molecular velocities. RMS velocity formula, square root of 3RT by M. Average velocity formula, it is very very important. RMS velocity, many problems are there. Previously in MSET many problems are asked by RMS velocity using. So average velocity square root of 8RT by M. Most probable velocity square root of 2RT by M. So it is indicated C bar, CP. So CP is to C bar is to CP is to C bar is to C. CP is to C bar is to C. So is equal to formula 1 is to 1.12 is to 1.224. So C bar and RMS velocity. Average velocity RMS velocity relation. Probable velocity RMS velocity relation. So next. So directly graphs, these two graphs are given. This curve, if it is 1, 2, 3, 4 or A, B, C, D. C curve indicates which of the following gas, or A curve indicates which of the following gas. So like that, these two are very very important, previously MSET questions. So next, van der Waals equation formula. It is the volume pressure correction or volume correction. P plus n square by v square into v minus nb equal to nRT. For n moles nRT, for 1 moles P plus A by v square into v minus b equal to RT. So pressure correction or volume correction, which of the following is pressure correction? Directly asked question. So units of A, liter square mole power minus 2. A is a measure of attractive forces. When attractive forces increases, the gases are easily liquefiable. So units of B, liter mole inverse. B, effective size of gas molecules. B indicates effective size of gases molecules. So when the size is, when smaller the B values and larger the A values, that gases are easily liquefiable. Very very important. Okay, note this. See the first question. The ratio of rates of diffusion of gases X and Y of molecular weights 36 and 64 is. So very easy. We know that the rate of diffusion of gas is inversely proportional to its square root of molecular weights. That means R1 by R2 is equal to square root of M2 by M1. So here Rx by Ry, that equal to molecular weights X 36, Y 64. So reverse, 64 by 36. 64 means root 64 8, root 36 6, 8 by 6 4 by 3. So the ratio is 4:3. So very important, very easy. So next question, the rate of diffusion of a gas A is root 5 times more than that of gas B. If the molar mass of A is x gram per mole, the molar mass of B is rate of diffusion of gas A, Ra by rate of diffusion of gas B, Rb, is equal to square root of mass of B by molecular weight of B by molecular weight of A, inversely proportional. So Ra, rate of diffusion of gas A is root 5 times more than that of gas B. That means root 5 times of gas B means Rb. Ra is equal to root 5 times Rb, Rb is Rb. So that equal to square root of molecular weight of mass of A is x grams. So it is x, we calculate Mb. So Rb cancel, squaring on both sides, root 5 whole square means 5, that equal to Mb by x. So that implies molecular weight of B or molar mass of B is 5x. So answer, molar mass of B is 5x. So answer B. So next question, 4 grams of an ideal gas A present in a vessel of volume V liters exerted a pressure 5 atmospheres at 300 kelvins. That is one condition. Weight is given, molar mass is given, volume V liters, pressure 5 atmospheres, temperature T. Another ideal gas is 16 grams weight, molar mass Mb, same volume, same temperature, the pressure is increased to 10 atmospheres. 5 atmosphere pressure is increased to gas 10 atmospheres. So what is the relation between MA and MB? We know that PV is equal to nRT. So P is equal to N by V RT. So P is equal to number of moles means weight by gram molecular weight, V into RT. So WRT by MB. The relation between molecular mass of A and molecular mass of B. So for first gas P1, PA is equal to WA by MA. So at same temperature, T constant, R constant, volume constant. So WA by MA. PB is equal to WB by MB because volume R, T are constants. So then PA by PB equal to WA by MA into MB by WB. So what is the pressure? So first pressure is 5 atmosphere. 5. So after final pressure is 10 atmosphere, the change is 5. That means pressure of B also 5. That equal to WA. Weight of A is 4 grams by MA into MB by weight of B is how many grams? 16 grams. So 4 in 16 4 times, 5 cancel 1. So MB by MA is equal to 4. That implies MB by MA is equal to 4. So that implies MB is equal to 4 MA. MB is equal to 4 MA. So answer MB is equal to 4 MA. D, option D. Very easy. You can see this. Okay, see the next question. Gases deviate from ideal behavior at high pressures because the gas molecules. So gases are present in the atmosphere. When you apply the high pressure, the gases are come close to each other, and when gases are come close to each other, the attractions between gases molecules increases. That means they can liquefy. So that means attract each other. When gases come close to each other, attractions, more attractions takes place. That's why attract each other. So high pressures, at high pressures and low temperatures, gases are converted into liquids. Okay, next question. A gaseous mixture of 2 moles of A, 3 moles of B, 5 moles of C and 10 moles of D. One of the gaseous mixture contains A, B, C, D, different moles in a vessel. Assuming that gases are ideal and partial pressure of C is given 1.5 atmosphere, the total pressure is. So already I gave the formula. Partial pressure is equal to total pressure into mole fraction of that gas. Partial pressure of C is equal to total pressure into mole fraction of C. What is the partial pressure value? 1.5 atmospheres. Total pressure means total pressure. Calculate the total pressure. So PT into mole fraction of C means number of moles of C by number of moles of A plus number of moles of B plus number of moles of total number of moles. Mole fraction of C means number of moles of C by total number of moles. So 1.5 is equal to PT into number of moles of C. How many moles are there? C moles. So 5 moles. So 5 by number of moles. All number of moles. Here 2 moles, 3 moles, 5 moles, 10 moles. Total 15. So 15. 15 no? Oh, sorry, 2 plus 3, 5, 5 plus 5, 10, 10 plus 10, 20. So 20 moles. So 5 in 24 times, 1 by 4. So PT is equal to, so total pressure is equal to 4 into 1.5, 6 atmospheres. So answer is 6. So answer D. So option D. So next, the compressibility factor of a real gas at high pressures. Very important. P plus van der Waals equation, P plus AN square by V square into V minus NB is equal to RT, nRT. For 1 mole, P plus A by V square into V minus B is equal to RT. For 1 mole, P plus A by V square into V minus B is equal to RT. At high pressures, at high pressure A by V square is negligible. Very important, and remember, at high pressures A by V square value is negligible. So that means P into V minus B is equal to RT. So PV minus PB multiply is equal to RT. So PV is equal to RT plus PB. If you divide with RT, PV by RT is equal to RT by RT plus PB by RT. So PV by RT means it is Z, that is a compressibility factor. PV by RT, Z is equal to RT by RT means 1 plus PB by RT. So answer is 1 plus compressibility factor. The compressibility factor Z is equal to 1 plus PB by RT. So option D. Yet low pressures, if he asks the question at low pressures, then B is negligible. B is negligible. So then P plus A by V square into V is equal to RT. Multiply PV plus AV by V square means A by V equal to RT. So PV is equal to RT minus A by V. So dividing with RT, PV by RT is equal to RT by RT minus A by RTV. PV by RT means Z, RT by RT 1 minus A by RTV. So it is, if he is asking at low pressures, Z is equal to 1 minus A by RTV. At high pressures, Z is equal to 1 plus PV by RT. Very, very important one. Okay. Next. It is a 19th July 2022 question. Okay, note this. See the next question. Which of the following gases has the maximum water mass constant A? So here very important one. NH3 is the answer. Why NH3 means? NH3 has high covalent, NH3 has high hydrogen bond. So hydrogen bonding is present in NH3. Remaining there is no hydrogen bonding. That's why van der Waals constant is A is more. So because more number of interactions, intermolecular forces of attraction is more, then van der Waals constant A is also more. So next question. 1 liter closed flask contains a mixture of 4 grams of methane and 4.4 grams of CO2. Two gases are present in 1 liter closed flask. So the pressure inside the flask at 27 degrees centigrade is very easy. So we know that PV is equal to nRT. So P is equal to nRT by V. So the given 4.4 grams CO2, 4 grams methane. So P is equal to number of moles of CH4 plus number of moles of CO2 into R into T by volume. So number of moles of CH4 means 4.4 grams of methane. 4 grams of methane. Weight by gram molecular weight of methane 16 plus number of moles of CO2. Weight 4.4 by gram molecular weight of CO2 44 into R value 0.0821. Temperature 273 kelvins because 27 degrees centigrade means 27 plus 273. 27 degrees centigrade means 27 plus 273 is equal to 300 kelvins. So 300 kelvins by volume 1 liter. So 4 by 16 means 1 by 4. 1 by 4 plus 4.4 by 40. 1 by 4 plus 4.4 by 44 means 1 by 10, 0.1 into 0.08 to 1 into 300. That means 1, 2. 8.1 into 3, 24.6. So 1 by 4 plus 0.1. That means 1 by 4 means 0.25. 0.25 plus 0.1 into 24.6. So 0.35 into 24.6. Neither value 8.62 atmospheres. So answer 8.62. So option A. Next, ninth question. The most probable velocity of a gas at 7200 kelvins is equal to the RMS velocity of helium gas at 27 degrees centigrade. The gas is. So the most probable velocity of unknown gas, whatever the gas, that is unknown gas. Most probable velocity of gas at 7200 kelvins. That means square root of 2RT by m1 is equal to square root of the RMS velocity means square root of 3RT by m2. It is T2, it is T1. So that implies square root of R cancel. Next, 2. T1 means 7000, the given temperature is 7200 kelvins by m1. So m1, we calculate the m1. Square root of 3 into T2. T2 means 27 degrees centigrade. 27 plus 273. 300 kelvins by m2. m2 means RMS velocity of, m2 means helium gas molecular weight. Helium gas molecular weight 4. So that implies squaring on both sides. 2 into 7200 by m1 is equal to 3 into 300. 900 by 4. So 0, 0, 0, 0 cancel. So that implies m1 is equal to 4 into 2 into 72 by 9. So 9 and 72 8 times. 8 into 2 16, 16 into 4 64. So 64 molecular weight compound is O2 means 16 plus 16 32. CO means 12 plus 16 28. Nitrogen 14 plus 14 28. Sulfur dioxide. Sulfur 32, 2 oxygen 32 64. So answer is D. So 64 molecular weight compound is sulfur dioxide. Okay, not this.